Hi, my name is Srini and this is a final project presentation for the project called Integrating Insights from Non-Structured Community Data into EHRs. We are a team of 6 members comprising of 4 developers and 2 project managers/QA. Before I speak about our work, let me give you all a little background on why we chose to do this. Why is such a project even necessary in the first place? We all understand that a clinician is a healthcare professional that works as a primary caregiver for a patient in a hospital, skilled nursing facility, or a clinic. Clinicians run into issues when they want to review their patient data from an external source like community health centers because these data sources don't follow any standard data definition. This makes it hard as a lot of unnecessary information gets accompanied with useful patient information that clinicians are primarily concerned about. Since time is an asset for clinicians, we have built this application that only extracts patient information that is relevant and valuable for a clinician. Using this data, a clinician is able to understand their patient's health history and progress quickly so they can provide their recommendations. Our application provides a unified view of all relevant patient data that is valuable to a clinician. Since data was not readily available for us to use, we chose the route to generate synthetic data by ourselves for the scope of this project. Here's an example of synthetic data that we have generated. You can see there is a lot of information that is not relevant and will not help a clinician perform his job efficiently. For example, there's organization code, there's participation ID, there's ethnicity of the patient, and there's education and so on. Let's look at our high-level architecture. Orange boxes represent the project-specific components we have built, and blue boxes represent the open source components we have consumed for this project in the semester. In this diagram, patient data represents the synthetic data we discussed earlier in our example. This patient data is sent to an extractor component, and then this data is ingested into our database in a FHIR-compatible format. This extractor component is responsible for extracting the patient data that is helpful for a clinician to understand his patient's history and how he has progressed over a period. We have built an insights component which is the brain of our front-end service. I will demonstrate our front end in just a little bit. Let us take a moment to understand how we operate with EHR, our second data source. As you can see, for the scope of this project, we have used Cerner as our EHR, and Smart on FHIR helps us in authorizing our front end to access the data available in Cerner EHR. In addition to accessing the Cerner EHR using Smart on FHIR, the backend server, which is our Insights component, also has a connection to other public FHIR servers to extract other information as necessary. Our application can work with both data sources and still be able to present this data to a clinician in a FHIR-compatible format. When I say both data sources, I'm talking about EHR, which has a standard data definition, and synthetic data, which has no standard data definition. Let's talk a little about our technical stack. We have used Node.js as our primary programming language. MongoDB is our choice for database in this project. GitHub has been integrated with Jenkins for self-deployment. Our application and MongoDB has been deployed as a Docker container. I promised earlier to go over our front end, so here we are. Let's go ahead and create a testing environment for an IHI provider which can access a record for multiple patients. Here we choose a patient called Timmy Smart, and here is a unified view of this patient's data that is valuable to a clinician. Our application has 4 primary sections, as you can see in the screen, and I will discuss each one of them with you. The first section shows the program type the patient has enrolled in along with their dates. It also provides the organization for each program type. On the right of the screen, we can observe that the number of sessions the patient has attended has grown over a period. The next section gives the actual measurement of the patient for each program type. The blue text indicates data coming from FHIR, and the black text indicates our synthetic data. As you can see, so there is different organizations like Burgers University Medical Center, there's Modern Weight Loss Program, there's Diabetes Management Organization, and so on. And you can see measurements for body mass index, body weight, body height, hemoglobin A1C, and so on. Moving on to the next section, trend analysis gives a holistic view of the patient's progress over a time period. It captures a clinician's attention and makes it easier for him to assess how his patient is responding to medication. In this example, we are discussing 2 program types, and we will show you the trend for both body weight and hemoglobin A1C levels. Looking at the body weight trend, this section gives a trend of the patient's body weight ranging from October 2007 all the way till July 2018. Let's look at the hemoglobin A1C trend. This also shows the trend ranging from August 2016 all the way till July 2018. Moving on to our next section, which is our analysis section, which tells us which gives us the analysis of the program type for this patient. In this case, we can observe that the patient has gained 10 pounds since starting this program and has lost his A1C level by 1%. This is for the Modern Weight Loss Program. When you talk about the Diabetes Management Org, the patient has gained 10 pounds and has lost 4% of his A1C level. In both these cases, the patient seems to be improving. Let's look at some further research. There is a lot of research in the areas of how to combine community health center data with EHR and FHIR. In this slide, we provide a few URLs that give more information. To conclude, with this demo, we proved that our application can integrate insights from non-structured data into EHRs. This project is built as a framework allowing anyone to extend the observations, adding corresponding ETLs as a plugin, and rendering more cards in the dashboard. Team Ninjas would like to thank our professors and mentors who helped us at every stage in this project. Thank you.